Hey guys, welcome back. Time to get back on this transformer on this Zenith 5S29, and my plans were to splice the conductors back under the bell housing here, but I really don't have much room there. I don't think I'm going to take any chances because these things can be pretty fragile. So I'm going to go ahead and do all my splicing here external after it leaves through the grommet and the base plate, and kind of get things dressed up. So I'm going to follow the RMA codes. These, of course, you can't really tell in some cases because the dyes or pigments used in the wiring has faded, but this Zenith transformer appears to have not used the RMA codes. Was adopted, I think, starting back in the 1920s. So anyway, I want to just kick off here, and I'll show. I think I'm going to use a different technique. I've used the coil method. I've used the hook method. I'm going to use a Western Union Lineman Splice, and then place heat shrink over it. So I'm going to just mock up one here so I can estimate what lead length I need, and then I'll be right back. Okay, as you can see here, I've got about 1.5 inches of bare wire now, kind of stripped back. So I'm going to go ahead and tin both pieces of wire, and again, what I'm starting with will be the 5-volt windings, and that actually feeds the rectifier tube. So tell you what I'm going to do on this old copper wire. Again, I've got it cleaned up pretty good, but I'm going to use my flux pen here and put just a little bit of flux on here, and then after I get that flux on, I'm going to just tin it real quick. I might as well just go ahead and put a little bit here as well. So let's get this tinned. Alright, let me repeat this on this lead and I'll be right back. Okay, let me show you how this Western Union Lineman Splice works. So you can see I'm in an X pattern here. I've got my conductor stripped back, and I've got about 1.5 inches. That may be too much, but I'm going to now take this conductor here coming from the transformer and pull it down, and I'm going to pull this one up. And what I want to do is have a minimum of 3 wraps, very tight, back against the conductor. And you can see I've definitely got plenty of lead to achieve my 3 turns. I'll go 4 total. Okay, that's my 4 on that side. Now let me make sure I can wrap these tight, and I left myself enough room to get 3 to 4. It's 2. Okay, now we'll cut these off. Okay, there you have it. Again, that's called a Western Union Lineman Splice. There may be other names for it. So let me stick a little bit of flux there and get this soldered up, and then I'm going to go ahead and repeat the same on the other leads. Okay, let's size up the heat shrink again. I just want it again to cover the solder connection, then back on the other outside sleeving just a bit to provide some stability. So I think that's good there. Again, I'll just make sure it's over the center of the splice. Let me just eye this one more time. And that should be good there. One thing I found that comes in real handy, get this thing to light. You guys can see it's this little portable microtherm heat shrink. This is what I use for my heat shrink. Sometimes I'll use an open flame, but this comes in really handy. Again, I'm going to just start here in the middle and work my way back toward the edges. Okay guys, just a real quick check of the work, and I think we're good. I think before I was reading about 0.1 ohm or so, and you can see that's where we're at. Okay, let's move on now to the 6.3 volt filaments, and again we'll be using green wire in this case. Again, that'll match up with the old RMA specs. So let me start working these conductors here. Okay, as you can see now, I have the filaments complete here with the new green leads. So next I'll, let's see, I think I'll tackle the primary input, which will be black, and that will be these two leads here. Okay, I've got the primary leads finished up, and I checked the DC resistance, and I'm right at 10 ohms, so I'm good there as well. So let's move over now and tackle the high voltage, which includes the center tap. Hey, I don't have a red wire in yellow, so what I'm going to do for my center tap is use yellow and then just put red bands around it. So that'll be close enough, and that'll be part of my documentation. So again, I'm just using the marker here, and you can see that should create some separation from the center tap, at least through the wiring process. If this fades off later on, no harm, no foul, because we'll be able to trace it back the way it's wired to the circuit. So again, here's my center tap lead now, all prepped up and ready to go. Again, I didn't have red yellow, so I made it yellow red and just used the Sharpie. So that should suffice. Now let me start with these other two leads here, and these are the high voltage secondary windings, and both of these will be red. Okay, moving along here to my secondary readings. I'm good. I'm reading 374 ohms. And I'm looking back at my notes, and it doesn't appear that I checked between the leads. I was actually between the center tap and each lead. Looks like I read 173 on one and 191 on the other. So let's see what we get. And again, for those following along, I didn't have a red yellow wire, so I used a yellow with red bands for my center tap, just using a Sharpie pen. So let's see, 197 now. I read 191 before. And let's see, we just leave that there and switch off to the other lead. And 179, 173 is what I had documented, 174. So everything looks good here, folks. So I tell you what I'll do, I've got to do a little bit of derusting here. Now this is pop riveted to this piece of metal frame. I've got to do some derusting here as well as on these laminates. So get this transformer back together, and then stay with me. I've got an update on the electrolytic capacitors for that Zenith 5S29. Something interesting. So thanks again for watching. I appreciate it. And thanks for subscribing to my channel.